All right, guys, well, welcome back. So we're going to continue now looking at what happens if you have something like a quadratic in the bottom that can't be factored. And again, remember, if you can factor, you can use partial fractions, and that's generally going to be the easy strategy. What if you have this, something with an x term? So 1 over an x squared minus 8x plus 17. If we just had a constant term, we can use the strategy with inverse tangent. But what if you have something like this? And the answer for how you're going to solve these is a strategy that you may remember called completing the square. So let me remind you really fast of the algebra version of completing the square. Okay, so in terms of algebra, you completed the square to solve an equation like this. And what you did is you took the x coefficient here and you divided it by 2 and then you squared it. So you did negative 6 over 2 is negative 3, and then you square negative 3 and you get 9. And then what you do is you add 9 to both sides of the equation. And the reason you do this is because after you do this completing this square, you end up getting something which you can factor. You can write this as an x minus 3 squared equals 13. And then, of course, you're able to like square root both sides, and you get like x minus 3 equals plus or minus root 13, and so forth. But the important part is this dividing by 2 and then squaring on the x coefficient, because that's exactly what we're going to do here. So let's go back and let's actually take a look at this example. So we are integrating 1 divided by x squared minus 8x plus 17. So what you're going to do, again, is you're going to try and simplify this. And the first step we'll do is complete the square on the x term. So we look at this. This is an 8. So 8 over 2, it doesn't matter, you're going to square it anyway, is negative 4. And then, of course, if you square that, you get 16. Now, when we had an equation like over here on the right side, we added 9 to both sides of the equation, but we don't have an equation here. So we can't add something to both sides because there aren't both sides. But what we're going to do is we're going to add and subtract that 16. Because I think you agree, if we can add 16 and then subtract 16, I'm not actually changing the integral. So what I'm doing is I'm going to add 16 here and I'm going to subtract 16 here. So I'm not changing the denominator again, I'm just kind of borrowing 16 from the 17. I'm moving that over to the left. Because you can rewrite this as 1 over x squared minus 8x plus 16 plus 1, and you can see that that's kind of the same thing, right? That's basically the same, well, it is the same thing as this. We just kind of split the 17 up into 2 parts by completing the square. Okay, now what I want us to do is to factor this. And this is, of course, it's completing the square, so it's going to turn into x minus 4 squared plus 1. And now I see a smile creeping up across your face because we could just do a u sub. So pick u equals x minus 4. The du is dx. So when we do that, we're just integrating 1 over u squared plus 1, which is, of course, just the inverse tangent of u. So this problem just turned out to be the inverse tangent of x minus 4 plus c, which I should have written here as well. Okay. So that's how you do that example. Let's do another one, and I'm going to do 2 more that kind of involve similar tricks. So in this next one, let's integrate 5 dx, and the constant on top is not going to affect much, 5 dx over x squared plus 12x plus 40. Okay, so again, we see the bottom cannot be factored, right? There's no way to factor that. So if you can't factor, that's your indication that you should complete the square. And hopefully, right, it makes sense that a u sub doesn't work because, your u would be x squared plus 12x plus 40, and then your du would be like a 2x plus 12, but we clearly don't have that, so that's not going to help. Okay, so let's complete the square on this part here. So 12 over 2 is equal to 6, and then, of course, 6 squared is 36. So I'm going to add a 36 here and borrow a 36 from the 40. So I'm going to write this as 5 dx over, and then this part right here, that factors to x plus 6 squared plus 4. Okay, now I'm going to do u sub. And then we're going to see something kind of cute is going to come in. So we're going to do u sub here with whatever this part is that's being squared, right? It's in parentheses. So u is x plus 6, so the du is just a dx. Nice. So this becomes the integral of 5 dx, and hey, we could just pull the 5 in front, right? It doesn't matter. You can leave it there. It doesn't matter either. But 5 over u squared plus 4, and that's a du. Sorry. Now, great. So we're integrating 1 over u squared plus 4. Isn't that the pattern we just did earlier in the class? Oh, that's just this right here. Oh man, cool. So you can walk through like the factoring out the 4 if you want. You don't have to. You can also just say, hey, I'm going to use this pattern. This is just 5 times, and then I'm going to have, square root of 4 is 2. So that's 1/2 inverse tangent of u over 2. And then we just have to make sure that we plug in the u that we got from up here. So again, this is the pattern that we derived in the last video. So this just becomes 5/2 inverse tangent of x plus 6 over 2 plus c. Okay, cool. So I know it's not the most beautiful strategy, but that's how you deal with kind of this type of problem by completing the square and getting something related to inverse tangent. Okay, so in the next example, let's talk about this. Let's say we have, for example, a 6dx over 3x squared plus 6x plus 30. Now you might think your goose is cooked because of the 3x squared, but it's not. So what I'm going to tell you on this guy is to factor out the x squared coefficient from the denominator. And then once we've done that, then we'll be able to complete the square. So what I'll do is I'll factor out the 3 on bottom. So this becomes integral of 6dx. I'll factor out a 3. I'm left with x squared plus 10. 10, that's terrible. Plus 2x plus 10. Okay, and then all the cool kids, notice we can cancel a 6 and a 3. Nice. So this just becomes integral 2dx over x squared plus 2x plus 10. Now I'm ready to go ahead and complete the square. Okay, so I'm going to look at this and I'm going to say, okay, well, 2x, 2 divided by 2 is 1, 1 squared is 1, so I'm going to add a 1 here, subtract a 1 here. So this will become integral 2dx over x plus 1 squared plus 9. And again, this has worked out very nicely, right? My u is x plus 1, my du, and remember, the u is just whatever squared. My du is at dx. So this becomes integral of 2 du over u squared plus 9. Of course, 9 is 3 squared, so we can use that pattern we derived earlier. So this just becomes 2 times 1/3 inverse tangent of u over 3 plus c. So this just becomes 2/3 inverse tangent of x plus 1 over 3 plus c. Okay, so that's how you handle these types of problems. Let's take a look at just a couple other examples, maybe one without a polynomial. So something like this. So this was actually an AP problem a couple years ago. You integrate e to the x dx over 1 plus e to the x plus 4 squared. Okay, now if you're dealing with something like this, I think hopefully one of your first indications would be to try a u sub, just because you see something in parentheses. So try a u sub first. And when you do that, your u is e to the x plus 4. The derivative of that is e to the x dx. And how beautiful we have an e to the x dx. So this becomes the integral of du over 1 plus u squared. And then again, we're back to just the inverse tangent, right? This is just a beautiful problem. This is just inverse tangent to u, aka inverse tangent of e to the x plus 4. Okay, great. The only other thing I wanted to share with you guys today is you might be wondering, well, what about like an inverse sine problem? Well, obviously, if we just integrate 1 over root 1 minus x squared, we know that that would just be inverse sine of x. And you could do similar tactics with completing the square. You got a negative, so it's kind of gross. But one of the things that is going to happen is you might be asked to take the integral of 1 over, square root 16 minus x squared. Now, again, I'm going to do the same thing I did with inverse tangent because I want a 1 here. But something really cute is going to happen with the square root. So what we're going to do is we're going to factor out the 16 inside the square root. So I'm going to turn this into, I should have put a dx here, but I'm going to turn this into, so if I factor a 16 inside the square root, that turns into 1 minus x squared over 16. Now, I can actually separate the square root, so I can turn that into square root of 16 times 1 minus x squared over 16. Okay, so the square root of 16, of course, we know is just 4. So that's 1/4 times 1 over 1 minus. And of course, x squared over 16, we want to write this in, just like we did with inverse tan, as x over 4 squared. So that's x over 4 squared, and this is all inside the square root. Okay, and then something really cool actually happens here that always happens on these problems. Once we have it to this point where I have something squared, that's where I do my u sub, right? So I'm going to pick u as x over 4. So then the derivative of that is a 1/4 dx. So we'll put a 1/4 by the dx because we need to match, so we'll balance with the 4 in front. But oh, how beautiful is that? The 4 and the 1/4 cancel. So you're actually just left with the integral of 1 over square root 1 minus u squared, and this whole thing becomes a du. And that's nice because that's just inverse tangent. Inverse tangent. What am I doing, guys? That just becomes inverse sine of u plus c. So that's just the inverse sine of x over 4 plus c. And the constant didn't even matter because of the square root. Okay, so that's how we deal with something with an inverse sine. When you see a square root, the denominator, you can't do a u sub. Try that. All right, thanks for watching, guys. Bring me questions to class. I'd love to help you guys with that. And, make sure to mash that subscribe and that like button so I can get more advertising revenue.